Today we're going to talk about the radian measurement of an angle. Okay, a radian, I believe you guys talked about it in geometry, I might be wrong. Understanding what a radian is more difficult than converting between degrees and radians. So if you're still a little confused, you're still going to be able to do the homework based on going back and forth between the two. A radian is another unit for an angle. It's a unit for, a unit for an angle. Sorry, a unit for an angle. It's kind of like how if you're measuring distance, you can measure distance in feet, in yards, in meters, in miles, right? There's a whole bunch of different measurements for distance. However, for angles, you have degrees. That's the main one that we talked about. You have degrees and you also have radians. So what a radian actually is the ratio of the length of the intercepted arc to the length of the radius. Okay, so copy that down. I'll make more sense of it now. The ratio of the length of the intercepted arc to the length of the radius. So a radian, for example, let's say I have this circle, right? Let's pretend that's a circle. Now, if I were to draw the radius here, oops. Right, so that's my radius. Let's say that that's that distance is 2, okay? If I'm talking about this angle measurement here, right, we'll call this theta. And let's say the intercepted arc, it starts, it's how much of the circle is intercepted between the initial side and the terminal side of your angle. So this would be the intercepted arc, okay? So let's just, for argument's sake, let's say that that's also 2. So again, the radian is the ratio of the length of the arc to the length of the radius. So this would be 2 over 2 radians, which is 1 radian. 1 radian. These are A's, not U's. 1 radian. Let's say I have this circle here. And we'll say that my radius here, we'll say that the radius is also 2. But now instead of the intercepted arc being 2, let's double it and say that the intercepted arc is 4. So again, this is just an approximation, but let's say this is 4. My angle in this case, you see how the arc is like doubled in size? Again, I'm the one drawing it, so it's a total approximation. But it doubled in size, so did the angle. So this is now, the intercepted arc is 4 over the radius is 2. So this is 2 radians. Okay, that's all it is. It sounds more confusing than it really is. Okay, so to convert between radians and degrees, I just want to show you where this comes from, right? So let's talk about this circle. And let's choose an angle measurement that we definitely know. Let's say I go all the way around the circle, right? We know that if you go all the way around, that would be 360 degrees, right? So 360 degrees, we're going to convert into radians. So I'm going to show you how to find that. So in this case, we're going to say that our radius is r. And then the intercepted arc would be the entire circle. It goes all the way around. If you go all the way around the circle, kind of like finding the perimeter of the circle, the name for that is the circumference. The circumference of a circle. And the circumference you find by doing 2 pi r. Right? So if I'm talking about 360 degrees, in radians, that would be the intercepted arc, which is the circumference, it goes all the way around, which is 2 pi r, divided by the radius, which is r. These cancel. So this is the conversion. 360 degrees is the same thing as 2 pi radians. Okay, that's really one of the most important ones that you should know. 360 degrees is 2 pi radians. If you were to divide each of those by 2, that means another important one is that 180 degrees is 1 pi, or just pi, radians. Remember, pi is 3.1415, blah, 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 blah. It's not a variable. So these are two important ones that you guys should know. 360 degrees is 2 pi radians, and 180 degrees is pi radians. Okay? So this is the conversion rules. If I give you a degree measure and I ask you to convert that into its equivalent radian measure, you are going to take the degree measure and divide it by 180 and then simplify. Okay? Divide by 180, simplify that fraction. Then you're going to add pi to the numerator. Okay, so let's just do those examples first. So if you look at the examples 1 through 3, I give you the degree, I want the radian. Okay, so that's my steps that I have on the left, going from degrees to radians. So this first example, 30 degrees, I'm going to take the degree measure, divide it by 180, and simplify that. So in the calculator, if you type in 30 divided by 180 and then you press math fraction enter, it'll give it to you as a simplified fraction. That simplified fraction is 1 over 6. Second step, add pi to the numerator. So it would be 1 pi over 6. You don't have to put the 1 in the top, but if you do, that's totally fine. So 30 degrees is pi over 6 radians, or 1/6 of a radian. 1/6 pi, radians. Let's try number 2. Again, degrees to radians, you're going to take the degree measure, divide that by 180, and simplify that fraction. That turns into 4 over 3, and then you throw the pi in the numerator. Okay? Number 3. Take the degree, divide by 180, and simplify that. This one will give me -7 over 4. So this is -7 pi over 4 radians. Okay? Even if you wanted to, I already told you before that 360 degrees is 2 pi. So 360 divided by 180 is 2. And that's really 2 over 1, so the pi goes in the numerator. Okay, so it works like that also. Then if you want to go the other way, it's actually even easier. To go the other way, you replace the pi that's in the radian with 180, and then you simplify it. Okay, that's 180 degrees. So here, number 4 is pi over 6. So I would do 180 divided by 6. Take out where you see pi, plug in 180. So 180 divided by 6 is 30 degrees. Just take a look at these two examples really quick. They go back and forth. Okay, so if I give you 30 degrees, you get pi over 6 radians. If I give you pi over 6 radians, you get 30 degrees. If you convert back and forth, you're going to get the same thing going back and forth. Okay, it's never changing. Number 5 pi over 3. So I'm going to take out the pi, throw in a 180 degrees, divided by 3. You can type that into your calculator if you want. 5 times 180 divided by 3 is 300 degrees. Okay? 300 degrees is in quadrant 4. So 5 pi over 3 radians is also in quadrant 4. It's the same angle, it's just a different way to measure it. Okay? And then number 6, last one. Take out the pi, throw in 180, divide by 10. You can type that right in the calculator. That gives you -54 degrees. okay? Negative 54 degrees is in quadrant 4, right? Because it's a negative angle, so you open up clockwise. And it's less than 90, so you're not passing over any quadrants. So negative 54 is in quadrant 4, which means negative 3 pi over 10 radians is also in quadrant 4. Okay? And that's it. Let me know if you have any questions. Your homework tomorrow is really just going to be it's just going to be like this, going back and forth between radian and degree measurement. Let me know if you have any questions. Have a good day.